Good morning, everyone. We're getting ready for some algebra right now. We have actually come to one of my favorite methods for graphing parabolas. Finally, I can't believe it's here. So let's take a sip of coffee and get started. Good morning. All right, using intercept form. So characteristics of this form right here, which you should highlight, that's A x plus p, x minus q. We're calling that intercept form. I usually just call that factored form, but okay, intercept form works for me. Here it is again, p plus q, p minus q, p x minus q, x minus p. Here we go. Write the function represented by each graph. Well, if you will remember, if you set a polynomial equal to 0, then the places where the polynomial is equal to 0, we call those the roots, and that's where the function crosses the x-axis. So here we've got, in that above equation, let's see if I can get that for you. Yeah, a right here, a is equal to 1. So that'll take care of some of the problems. So all we really need to do is find out the roots. So where does this cross the x-axis? Well, there are two places right here, right there, right there. That happens at x equals 1 and x equals, I think that's 2. So if I want to write that in intercept form or factored form, then f of x is going to be equal to x minus 1 and then x minus 2. And that's really all there is to it. If your curve crosses the x-axis at 1 and 2, then your polynomial should have an x minus 1 and an x minus 2. This one over here, maybe we should zoom into these. All right, that's a sufficient zoom. This one here has the exact same roots, x minus 1 and x minus 2, or x equals 2. So when I write this one, I'm still going to need an x minus 1 and an x minus 2. But the difference is this parabola opens downward. So to get this parabola to open downward, you're going to need a to be negative. In this case, we're told a is always either positive 1 or negative 1, so I'm not going to worry about that. I'm just going to put a negative sign in front of it and move on. I think you know how this game is played. So take a second right here, do question 6, and pause it, and we'll come back with the answer. Okay, coming back now, hopefully you saw that the two roots were 0 right here and 3 right there, which means that in factored form or in intercept form, you should have, I should be pointing this direction, in intercept form, you should have x minus 0 and x minus 3. Well, x minus 0 is just x, so you'll probably never see it written like this by any teacher or anyone who wants to look academic. But it is the same thing. X minus 0 is the same thing as x. This is perfectly acceptable, and this should be perfectly acceptable. You might run into problems if you were going to take a multiple choice test, but we can't really control that one. So there are loads of these up and down here. We should probably do one that involves a negative root. So I think letter E will suit our purposes just fine. Let's figure out the roots on this one. We've got x equals 0 right here. We've got x equals negative 3. So when I do this one, f of x will be, Well, we've learned if x equals 0 is one of the roots, we don't have to write minus 0, we can just write x. And then this is x minus negative 3. Well, x minus negative 3 is a little bit redundant, so just like before, you probably never see it written as x minus negative 3. You'll always pretty much see that as x equals 3. Okay, let's move on to the rest of this. More stuff, you don't have to worry about those. I think we figured out what are some characteristics of x minus p and x minus q. Well, p and q are the roots of the graph. Yeah, and a, just like before, a is lattice points. You probably won't see this. And a also says direction. Remember, direction for a parabola in Algebra 1 is either up or down. Let's turn these into something that's not handwritten, and we'll move on. Number 3 says, consider the graph of f of x equals a, x minus p, x minus q. Does changing the sign change the intercepts? Changing the sign of a, that is. Does that change the intercepts? Does changing the sign of a change the y-intercepts? So yes, it does change the x-intercepts. I mean, no, a does not affect the x-intercepts. Since a affects direction, it will affect the y-intercept. So you'll imagine, let's just go back to our examples up here. You know, the y-intercept here is positive 2, while the y-intercept down over here, that's negative 2. So the only thing that changed between a and b is that the value of a changed from positive 1 to negative 1. So yeah, it does change the y-intercept, and you can imagine that that's true because it's the difference of opening upwards versus opening downwards. So the y-intercept is affected, but the x-intercept is not. Does changing the value of p change the x-intercept? Yes. P is actually the value of one of the x-intercepts, so if you change p, obviously you're going to change at least one of the x-intercepts. Does changing the value of p change the y-intercept? P affects the whole shape of the parabola, so if you're changing the whole shape of the parabola based upon p, then of course the y-intercept is going to, or there will be consequences for the y-intercept. So where does that leave us? Intercept form, I think we all know what that looks like now. Y is equal to a, x minus p, x minus q. Here are some tips on graphing. One thing that we didn't touch upon is the axis of symmetry. So you'll remember in the last video we were saying that the axis of symmetry, and therefore the vertex, is always halfway in between the roots. So if the roots are p and q, then the axis of symmetry, and therefore the vertex, needs to be when x equals p plus q divided by 2, basically the midpoint. And honestly, I never really use that formula. I just figure out what number is in between the roots. I mean, if the roots are 0, 0, and 4, I just think to myself, well, what number is in between 0 and 4? 2, duh. So, next rules, they should make sense. If a is greater than 0, then the graph opens upwards. If a is less than 0, the graph opens downwards. That's been consistent all the way throughout our algebra journey into parabolas. So yeah, this all looks pretty good. It's actually pretty easy, I think. Hopefully I can get you to think that too. factors of 0 for any factor x equals n of a polynomial. N is the 0 of the function defined by the polynomial. So remember, 0 and root mean the same thing. 0 is probably more descriptive, but I'm old school, so we say root in the old sense. Sorry about that. 0, root, same thing. Right, so find the x-intercepts and the axis of symmetry. These you'll figure out really soon why this has been so powerful for us, or why this will be so powerful for us. What are the roots here? Well, that's just quick maths. Okay, x equals -2, x equals 4. Those are the x-intercepts, which are the same thing as the roots, which are the same thing as the zeros, which is the same thing as quick maths. Okay, so that is where x equals -2, x equals 4. That's where our roots are our x-intercepts. And now let's figure out what number is in between -2 and 4. That might be a little more difficult, but you can always resort to the formula. What's -2 plus 4? That's 2. 2 divided by 2 is 1. So the axis of symmetry is x equals 1. No problem, right? Over here, number 2, -3 doesn't have anything to do with the roots. It just changes the shape, but not the roots. So we just need to look here and do our quick maths. X equals 2, x equals 3. Those are the x-intercepts. You should probably label that x-intercepts. How about the axis of symmetry? Well, what number is in between 2 and 3? I don't even have to do any math there. I know that's x equals 2.5. There we go. Let's take a look at the next few of these. Number 3. We've got x plus 5, x plus 1, quick maths. That means that I have roots at x equals -5 and x equals -1. 1, here's -1. -1, 2, 3, 4, 5. Here's x equals -5. Now those roots are really far apart from each other, so it's going to be, no, you know what we should do next? I think I saw that we need to figure out the axis of symmetry, right? Yeah, we need to label the vertex and the axis of symmetry. So let's figure out the axis of symmetry. What number is in between -1 and -5? Here's a good math tip for you, pro tip. I don't know. If both of these roots are negative, well, then we can just treat them like they're positive and make the result negative. What do I mean by that? Well, what number is in between 1 and 5? It looks like it's 3. So the number between -1 and -5, that's -3. So now we can make our -1, -2, -3. We can make our axis of symmetry here, right over here. And if I want to find the axis of symmetry, sorry, I'm just labeling x equals -3. If I want to find the vertex now, all I need to do is put -3 into mx. So the vertex, okay, we need to find, we know the x coordinate is going to be -3, but we don't know what the y coordinate is going to be. Let's figure out the y coordinate. The y coordinate is going to be -3 plus 5, and then -3 plus 1. Okay. How much is -3 plus 5? Well, that's the same thing as 5 minus 3, or 2. How much is -3 plus 1? Well, that's the same thing as 1 minus 3, so -2. How much is 2 times -2? -4. So what is our vertex? It's 3 and -4. 1, 2, 3, 4. Here's our vertex. All right, we got our 3 points. We can go ahead and graph this guy. Let's graph this. Ever since I started graphing like this, I've been addicted to it. It's pleasing to see such nice looking graphs, even if, someone might say they look kind of fuzzy. Well, whatever. They don't need to be great lines like that. Okay, so that looks really good. The shape is beautiful. Got a parabola. It's not a parabola that comes up vertically. It keeps on shooting out diagonally. That looks funny in screenshot. So here is our graph. Doesn't that look great? I think it looks great. Let's take a look at number 4. We'll do number 4. No, let's go on to number 6. I think you've had enough of these ones. Number 6. This one is not in factored form. So, you could spend your time going ahead and doing what we did in the last section. Notice you have a negative 15 here, plus 2. But you could also factor this. And I'm looking at this and I'm saying this is a pretty easy factor. 2 numbers that multiply to make negative 15, add to make 2. That's pretty easy. That's 5 minus 3. So f of x is just x minus 3 and x plus 5. Quick maths, that tells me that my roots are x equals 3 and x equals negative 5, which means that I'm going to have to move one of these. Let's move that, move the y-axis. Okay, that's good enough. And let's figure out where our roots are. Oh, I'm taking a look at this and I see a equals 1, which means I should, no, let's leave it. We're fine. Let's graph the roots as x-intercepts the zeros. You got x equals negative 5, 1, 2, 3, 4, 5. Here's x equals negative 5. We got x equals 3, 1, 2, 3. And, good rule of thumb is the further apart your roots are from each other, the further down or the further up from the axis your vertex is going to be. So what number is in between negative 3 and 5? Let's see. Let's add them together. 3 plus negative 5 is negative 2. Negative 2 divided by 2 is negative 1. Conversely, or also, you could have just eyeballed that and figured out exactly where that is. There's nothing wrong with visualizing where things are. Don't let any math teacher ever tell you otherwise. So negative 1, and now that we know that the axis of symmetry is x equals negative 1, we can substitute into our function again and figure out where the vertex is. You can substitute into this form, you can substitute into this form. If you had another form, you can substitute it into that form. It doesn't matter as long as you substitute into some f of x for the same problem. Don't substitute into problem number 5. That doesn't make any sense at all to me. Negative 1, let's figure out f of negative 1, and let's put it into our factored form. This is negative 1 minus 3, negative 1 plus 5. I find the factored form really easy to evaluate for any parabola. That is negative 4 multiplied by 4, which is negative 16. Wow, how are we going to get to negative 16? I only have 1, 2, 3, 4, 5, 6, 7, 8 spaces. What are we going to do? Well, one thing you can do is change the scaling. Let's just make this, if this is 1, 2, 3, let's make this negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, and negative 16. It's like I meant it to do that, but I really didn't mean it to do that, to get all the way down to the bottom here. All right, so here is our vertex at -1, -16. All you need to do now is draw your parabola. Ta-da! Here's our parabola for number 6. That's good enough for me. Is there more to this? Well, of course there's more to this. Find the zeros of the function. I'm going to give you a second here to go ahead and take a look at that. Realize that it is in factored form, so you'll need to factor first, and then you can read off the zeros. So take a minute, factor that. I'll come back when I'm factored. Did you get 6x squared minus 1? Okay, we're not completely factored yet. We can still factor x squared minus 1. Hint, x squared is a perfect square and 1 is a perfect square, so that's a difference of perfect squares. Okay, there we are factored. So where are the roots? X equals -1 and x equals +1. Lovely. Number 8. Go ahead and factor that. All right, did you get x plus 4x plus 5? I did. And let's figure out that's x equals -4 and x equals -5. Why did I put a parenthesis there? Okay, numbers 9 and 10. I think we're going to do numbers 9 and 12, and then we're done for today. Let's see. Let's do this one to get this to X-Intercept, just intercept form. To get this to intercept form, you're going to have to factor that. Let me zoom into this problem and take a second and factor that. Oh, wait. X minus 5, x plus 2. Take another second and figure out your axis of symmetry and your vertex. I'll wait for you. There we go. Axis of symmetry is -1.5. Now you might be weirded out by having an axis of symmetry that's -1.5. That's fractional and all. Let's just substitute that in there and figure out what we got. You have -1.5 minus 5, -1.5 plus 2. Let's see, -1.5 minus 5 is -6.5. -1.5 plus 2, that's the same thing as 2 minus 1.5, which is just, 0.5. And what's half of 6.5? Well, that's 3.25, -3.25. So let's put that point in here, -1, 2, 3, about a quarter of the way down, and let's draw your parabola. Here's our parabola, and I'm going to take a minute here. I'm going to let you guys figure out number 12 on your own. We'll come back with the answer, and then we'll say peace out, okay? Go ahead, and I'll just bob my head while you work. Let's do it this way for a while. Yeah. Well, silly me for not really looking at this. This is not a parabola. This is actually going to be a cubic function. Cubic function is what we call things with the highest power of 3, like you saw up over here. So when you graph a cubic function, the shape is always like that, or like that. So in some math that you haven't learned yet, we know that this is going to be the correct shape. Again, you never learned that. So I'm going to just try to quickly sketch that on this curve, and then we're going to be done here. It's kind of like two parabolas stuck on top of each other, isn't it? One downward opening parabola, one upward opening parabola. Okay, that's it for us today. Have a good time and, enjoy your maths. I know I always enjoy my maths. I'll see you guys next time.